Okay, so in the last class, we have seen the questions of stoichiometry where with the chemical reaction, we are given with the amount of one substance and we have to calculate the amount of any other substance. And we attempted those kind of a questions. For example, have a look at this question, let's suppose. See, a solution of tartaric acid was titrated with 1 mole per dm cube potassium hydroxide. It required 6 centimeter cube of potassium hydroxide solution to neutralize 20 centimeter cube of tartaric acid. So this is the volume of tartaric acid. This is the volume of potassium hydroxide. And here it is the concentration of potassium hydroxide, right? So as I have told you, first look at the substance whose amounts are given and you need to convert it into moles. Okay, now what is required? Calculate the concentration in mole per dm cube of tartaric acid. Okay, so this type of question can be done by two ways. One way is the one which I was discussing with you guys earlier, that what I need to do, I have to convert the moles of find the moles of potassium hydroxide. Yeah, then we have to do the ratio. Okay, so it's concentration times volume, right? So concentration of potassium hydroxide is 0.100 and volume is 6.00. Volume we have to convert it into decimeter cube always. So I divide it with the 1000. So can anyone tell me the answer? I think it is going to be 6 exponent minus 4 if I'm not wrong. Yes, these are the number of moles?
Yes, sir.
Okay.
Yes, sir.
Okay. Now, what I will do, I will do the ratio of potassium hydroxide with tartaric acid. So if you see the ratio, 2 moles of potassium hydroxide is reacting with 1 mole of tartaric acid. So if the moles of potassium hydroxide is 6.0 exponent minus 4, then the moles of tartaric acid would be x. And if you calculate the x, it would be 3.0 exponent minus 4. So we got the moles of tartaric acid. Here we have a volume of tartaric acid that is provided in the question, that is 20 centimeter cube. So if I have to find the concentration, so concentration of tartaric acid would be 3.0 exponent minus 4 divided by 20 over 1000. So I will get the unit mole per dm cube.
0.01.
0.0 5 moles per dm cube. So these type of a question that we did in the last class as well, and I have told you the way of attempting these kind of question, that first what you need to do, whatever substance amount is given, convert it into moles, then with the help of the balanced equation take the mole ratio, and then you will got the moles of the required substance and then convert those moles into the asked amount, whatever the amount is asked. Now we have the next thing is the limiting reactant. So first you need to understand the concept of limiting reactant. Okay, first note these down, then I will explain. So limiting reactant is the one which actually consumed earlier in the reaction, and as a result the reaction stops. And the excess one is the one which stays under some of the amount is left unreacted, that is the excess one. Is this clear? Okay, just complete this, then I will explain you how. Yes, everybody done?
Yes, sir.
Yes.
Okay. Yes, are you done as well? Okay. So first thing that you need to understand is the mole ratio in the balanced equation is the perfect ratio between the reactants and if this same ratio exists, then no one is limiting or in excess. If this same ratio exists, then no one is limiting or in excess. Is this point is clear? So you have to keep this thing in mind that if your reactants are actually existing in the same ratio as the mole ratio of the balanced equation, then it means that they are in the perfect ratio and no one is in the excess or in the limiting form. Is this clear to all of you?
Sir, I didn't get it.
Okay, I will explain it. I will give you the example. Okay. Okay, let's take an example of this. For example, if you have to make a one cheese sandwich, how many breads you need? Two. If you look at the top, you will find you will need a one slice and two breads, and it will result in a one cheese sandwich, right? So if I have to make a cheese sandwich, I have used two breads and one cheese slice, and I'm getting one sandwich. Is this clear to all of you? Now see, from the above, from the top, I'm getting the ratio of the breads and the slices. That how many bread slices and how many cheese slices I need. For example, now if for example I had a 4 bread slices and 2 cheese slices, so again they are in the perfect ratio. If I have a 6 bread slices and 3 cheese slices, I'm again in the perfect ratio. So see, I'm getting the 3 sandwiches and neither I'm not getting anything left over, right? Or anything unreacted. Yes, Khatija, did you understand this?
Yes, sir.
So see, they are in the perfect ratio, right? Now see, if I remove one sandwich, one cheese slice. So if you see, when I remove the cheese slice, I will get the 2 bread slices unreacted or unprepared. So it means that the bread right now becomes in excess and the cheese slice, because of the lack of a cheese slice, we are not able to make the 4th sandwich, right? So the cheese slice is the limiting reactant. Is this understandable?
Yes, sir.
Yes, is it clear to all of you? Saad, Aisha? Now, have a look in terms of equation now. For example, you have a 2 moles of, on the top, we have a balanced equation. We have a 2 moles of hydrogen reacting with 1 mole of oxygen, forming 2 moles of water, right? So, if I use 2 moles of hydrogen, 1 mole of oxygen, see, I am getting 2 moles of water. If I am using 4 moles of water and 2 moles of oxygen, I am getting 4 moles of water. See, nothing is left, none of the reactants. So it means my reactants are right now in a perfect ratio because all of the reactants, hydrogen and oxygen, are converting into product. Is this clear to all of you? Now see, if I make hydrogens 2, if I make hydrogens less, so see, I have a 4 hydrogen, but I have a 3 oxygen. So if you compare the amount without looking at the product or without the balance equation, you say what hydrogen are in greater amount, they have a 4 moles. But according to the equation, if you see that, you will able to identify that hydrogen is exactly not in excess but it's a limiting. Because if you see, for 2 moles of hydrogen, we need 1 mole of oxygen, and we have a 3 moles of oxygen. So if there are 3 moles of oxygen, then how much of hydrogen we need? 6. But there are lesser than 6. So it means hydrogen is a limiting reactant and oxygen is excess in this case. Is this understandable?
Yes, sir.
Okay. Now, if I, for example, see, now again they becomes in the perfect ratio. But if I remove 1 more oxygen, now hydrogen becomes excess and oxygen become limiting. Okay, you will take another example. Now, if you see this example, in this 1 mole of methane reacting with 2 moles of oxygen, forming 1 mole of carbon dioxide and 2 moles of water. So it means if I have a 1 mole of methane, for that 1 mole of methane, how many oxygen I have needed? 2. So see, that is the perfect ratio. If I have a 2 moles, then I need 4 moles of oxygen. So, but for example, now see, if with 2 moles of methane, I am using 5 moles of oxygen, so that 5th mole becomes an excess. So oxygen becomes the excess one and the methane becomes the limiting reactant. Is this understandable? And if
Yes,
I
sir.
remove methane, so methane become limiting and oxygen becomes excess. Okay, so actually, we have to identify this thing. For example, let me write an equation. There is a nitrogen gas which is reacting with 3 moles of hydrogen, forming 2 moles of ammonia. So I already balanced the equation. So I have a perfect ratio, and that ratio is telling me that for 1 mole of nitrogen, 3 moles of hydrogens are needed, right? So, okay. So think, if I have 2 moles of nitrogen, then how many hydrogens are needed? 6. If
6,
there are 3 moles, how many hydrogen are needed? If there are
9,
4 moles, how many hydrogen are needed?
12.
So all of this is the perfect ratio. Both the reactants exist in the perfect ratio, as I have written over here, over top, that if the reactants are in perfect ratio, then no one is in limiting and no one is in excess. Is this understandable? Yes. Yes, is this clear to all of you? Now think, if I provide you, let's suppose, 7 and 20. Now, can you tell me whether it's a perfect ratio or not?
No,
No.
sir.
Then according to the ratio, which substance is greater or which substance is lesser? Hydrogen is lesser. Very good, Ammar, because if you see the ratio is 1:3, right? So if there are 7 moles, then this must be 3 times 7. For 7 moles, I need 21 moles of hydrogen. But instead of 21 moles of hydrogen, I have a 20 moles of hydrogen, which indicates me that it becomes the limiting reactant. And this becomes excess. Now, for example, if I take 30 moles of this and 7 moles of, sorry, not 9 moles of this. So are they in the perfect ratio? Which one is lower than the perfect ratio? Now, because as you see, the ratio is 3:1. So for 30 moles of nitrogen, 10 moles of, for 30 moles of hydrogen, 10 moles of nitrogen must be there. But instead of 10 moles of nitrogen, we have a 9, which is lesser than the actual, the amount which is needed. So this makes, in this case, nitrogen limiting and this one excess. Is this clear? Yes, Aisha, Saad and Sami, if any one of you has any confusion, please ask. Yes, Khatija.
Clear, sir.
Okay. Now, another thing that you need to understand, normally, if you look any one of the question, let me show you. I am telling you how to identify the question is based on limiting reactant or not. In this, how many reactants are there? Yes. How many reactants we have? 2. But if you read the comprehension, this question, out of these 2, how many reactants amount is given to you? If you read this, see, out of 2, how many reactants amount is given to you? Only 1? For nitrogen monoxide. Right? Now, have a look at another question. If you look over here, see, the mass of the iron 2 ions can be determined by the reaction of iron 2 ions and acidified potassium bentonate. There are 2 reactants, right? But if you read the next line, you will understand they have given you the amount of one substance only. They didn't provide you the amount of other substance.
Sulfuric acid.
Amount. Where is the amount of sulfuric acid?
Sodium now.
But sulfuric acid is not a reactant. He dissolved the sample in 25. If you see, the reactants are only 2, the iron ions and the cheminophore. And out of these 2, they have given you the amount of one reactant. So, have a look over here. There are how many reactants?
2.
2. And they have given you the amount of only one reactant. Right? So, whenever there is a question for a limiting reactant, they will provide you amount of both the reactants in the question. Okay? So, this is the rule, amount of both the reactants is provided in question, and if you need to find the amount of product, then it is, that is the most important thing, that then it is calculated by using the ratio. Obviously we have to take the ratio of the with the product, but ratio with limiting reactant. We have to relate when we take the ratio. We don't take the ratio with any one of the reactant. First we have to find the limiting reactant, and then we take the ratio with the limiting reactant and the product to find the amount of product. Okay, now if you look at this question, a 2.34 gram sample of aluminium reacts with C. You are given with the amount of both the substances. You are given with the mass of aluminium, and you are given with the volume and concentration of sulfuric acid. And see, they have asked you, you have to show that the aluminium is in excess. So in this part, they have actually told you which one is in excess, but now you have to justify that. So what you will do, the first thing that you guys have to do, turn the amounts into moles, both the amounts into moles. So the aluminium that I have is 2.34 gram. I divide that mass of aluminium with its AR, which is 27. Can anyone tell me the answer, please? Then I will find the moles of sulfuric acid by multiplying its concentration by its volume, and that volume must be converted into DMQ. Yes, 0.087 moles. Okay, 0.1 moles. So basically, these are those moles which are available to us. Now we have to see whether these moles are in the perfect ratio or any one of them are in excess. Okay. So these are available to us. Okay. Now, if I take the ratio of aluminium and sulfuric acid, what is their perfect ratio? That for 2 moles of aluminium, 3 moles of sulfuric acid is needed. That is the perfect ratio, right? That I have took from the balanced equation. Now, remember, the easiest way of doing this, when they ask you that the one which is in excess, and they have asking you to justify that one is in excess, so make that X and take the amount of the other substance, the available amount of the other substance. Sorry. Yeah. So sulfuric acid, we are available with 0.1 moles. We are available with 0.087 moles of aluminium. Now, from here, the whatever the amount of moles we got, that is the moles which are needed, which are actually needed for these moles. So if this amount comes lesser than this one, which shows that it's in excess. So if you will calculate the value of X, it will be 2 times 0.1 divided by 3. So what is the answer? 0.067. So these are the moles of aluminium which is actually needed to react, right? And in actual we have 0.087 moles. So we have a greater amount of aluminium than the amount which we need. So it clearly indicates that it is in excess. Is this clear to all of you? So you will write a statement in the end that aluminium is in excess because 0.067 moles are needed and 0.087 moles are available. Is this clear?
Yes, sir.
Okay. Now, the next question you guys will do and show me you're working. And in the next class, we will be doing, the percentage yield and security, then the whole modes will be completed. Yeah. Then we will start with the organic.
इनका क्या होता है
Hmm.
इनका टॉलरेंस पे
You don't have a periodic table. It's 65. Okay. We got something we can लिया?
Yes, sir.
Okay. Now, as they have asked you to show hydrochloric acid is in excess. So first what you will do? You will find the moles of zinc, which is 2.34 divided by 65. This what is the answer? Then we will 0.036. Then we will find the moles of HCl, which is its concentration times volume divided by 1000. So I think you will get 0.1. So these are the moles of both the substance which is available. Now, as they have told you to show HCl is in excess. So I'll take the ratio from the equation. I'll make HCl X and use the available amount of 0.1 of zinc. So if you calculate the X, what you will get? Yeah, sorry, I'm doing the mistake. 0.036. Yeah, for 0.036. Yeah, 0.072 moles of HCl. So see, these are the moles of HCl which are needed and these are available. So the available ones are more, indicating that HCl is in excess. So you will write the statement like this over here, that HCl is in excess because 0.072 moles are needed and 0.1 moles are available. Yes, is this clear to all of you?
Yes, sir. Sir, I have a question.
Yeah.
That if the same question comes for the limiting factor, that we have to show that this is a limiting
The
factor,
same way.
then we will place
No. If, for example, they have asked you, if this question is for a limiting reactant, then how the question is being made? They show by calculation that zinc is the limiting reactant in this reaction.
okay. The rest of the calculation will
We
be
will keep the zinc X. Okay, we'll keep the zinc X and we'll put this value. The value which we got over here would be lesser than this one. So sorry, that would be more than this one. That makes it, limiting reactant, because this is the amount which is needed, and the needed amount is not we have actually the lesser amount than that one. So you will do the same thing.
okay, sir. And sir, if we have to identify between the limiting and excess, and it is not written that show that this is a in excess.
So you will do this way only. You can make and take the amount of anyone and make the other one limiting, other one X. For example, I will show you how. I had a one question like this. Okay. Yeah. Have a look over there, over here. I think in the previous class, I actually skipped that question. See this one. Here, examiner didn't mention which one is in excess. This one, starting from B1. See, what examiner asked you? Calculate the number of moles of silver nitrate contained in 30 centimeter cube, 1.5 mole per dm cube. Okay, let's calculate the moles of silver nitrate. So, concentration is 1.5 times 30 divided by 1000. So it will be converted into decimeter cube.
0.04.
0.045. So I got the moles of silver nitrate, right? Then calculate the number of moles of sodium bromide contained in 50 centimeter cube, 1 mole. So moles of sodium bromide is equals to 1.0 times 50 divided by 1000. 0.05 moles sodium bromide. Till here, is this clear to all of you? Okay, now
Yes, sir.
sodium bromide reacts with silver nitrate. See, both are the reactants. Using the equation and your answers to be to calculate the mass of silver bromide. So see what I have told you. When you have to find the amount of the product, first you have to identify which one is the limiting. And you will find the amount with the help of a limiting. Now see, according to the equation, their ratio is 1:1. Yeah. The mole must be same for both. But if you see, sodium bromide have 0.05 moles So it means for this amount of sodium bromide, silver nitrate must also be 0.05. But it is not. Yeah.
0.045.
Yeah, you can compare it in any way, you will get the same result. Yes, if you compare this, you can say for 0.045 moles, I need 0.045 moles of sodium bromide, but it is in excess. So this one is my limiting reactant because the ratio is 1:1. Okay, so you will take the ratio of silver nitrate with silver bromide. So the moles of silver nitrate, and you will do the same thing according to the equation. Their perfect ratio is 1:1. Then we have this much moles, and the value of X would be 0.045. Is this clear? Now I have to find the mass, so I will multiply it with AR, oh sorry, MR of the compound, so which would be 108 plus 80. If you will multiply it, you will get the answer. It's 188, 45%. I don't.
8.4.
8.
0.05 से multiply कर सकते हैं.
Yeah, 0.045 times this.
0.05 से multiply करें.
Then you will not get the correct answer.
So,
Then you will get the greater amount.
दोनों से निकल सकते हैं.
No, that's what I am telling you. You can't use both because see, both are not in the same ratio. If you look into
हमें क्या पता कौन सा पहले ratio.
you have a balanced equation.
0.05 क्या पता सही हो सकता है.
No, because if the 0. Okay, tell me how much silver nitrate you have
0.045.
and how much silver sodium bromide you have.
0.0.
So which one reacts completely? Why?
0.045.
0.045 would react completely
अच्छा हुआ.
because it's the limiting over here.
Product बन गया.
Yeah, the product is made from this amount. Some of this much must be left unreacted.
Reactions.
Yeah, excess. So we cannot. If you can do this with this, your answer will be marked wrong. So 0.045. Yeah, what was the answer? 8.46. Sorry, grams. Yes, is this clear?
Yes, sir.
Okay, I have uploaded the recordings till I think metals, no, redox, and then I will start uploading electrochemistry.
You do know.
Yeah. Okay, so I think I will upload these modes first so you guys can review this again, and then the rest of the topics which are left. Okay, so see you everyone on Thursday, and we will be starting percentage purity and percentage yield.
Most लोग खत्म होते हैं.
Yeah, then the whole mole will be completed. Okay.
Friday वो
Okay, then take care everyone. Allah Hafiz.
Yeah.